Hmm. Good morning, one and all. Yesterday video we have seen joint probability. So basics of joint probability as well as some expressions, right? Expectation of random variable x and y, covariance of random variables x and y, variance of random variable x and y, right? Similarly, correlation of x and y. These expressions we have seen yesterday. So this today's video continue part of yesterday's, right? Now here, before going to see some examples, we have some notes. We have some note. Here, if x and y are independent random variables, then your first condition. If we have expectation of x y is equal to expectation of x into expectation of y, right? When it is, if we have a random variable x and y are the independent variables, there are independent variables, then expectation of x y is expectation of x into expectation of y. Similarly, this, if we have a random variables are independent, so covariance of independent is equal to 0. Covariance of x comma y is equal to 0. Similarly, correlation of x comma y also a 0. When it is x and y are the independent random variables, so both values are 0. Then remark, here you know the expressions. Covariance of x comma y equal to expectation of x minus z, average of x, mean value of x, random variable x. So whole square equal to variance of x, or you can write it as a delta x square. Right? Here, variance of x equal to, so expectation of x square minus 2 into x mu x plus mu x square, or expectation of x square minus 2 into expectation of x mu x plus mu x whole square into expectation of 1. Right? So after that, finally we get the variance of, when it is, if we have a independent random variables, so variance of x equal to delta x square equal to expectation of x square minus expectation of x whole square. Follow? Just remember this note and this remarks. Now I will go for some example. Considering one example. Example is the joint distribution of two random variables. Joint distribution of two random variables x and y is as follows. Here you have a random variable x, so these are x, so this is x1, x2, right? x1 equal to 1, x2 equal to 2, and second and table, x table, right? So which is equal to, I am taking x side, so which is equal to 5j, right? So these are y1, y2, y3. So this is given data. So this is J11, J12, J13, J21, J22, J23, like this, right? Then using this random variables, compute the following. So one is, so first A, expectation of x and expectation of y. Then B is expectation of xy. So C is standard deviation, so delta x and delta y. So covariance of x comma y. So E1 is correlation of x comma y. So these we need to find. The total value is 5. We need to compute the 5 values. Now solution procedure is, now here using, if we need expectation of x, expectation of y, before that by the marginal distribution of random variables x and y. Marginal distribution of random variables x and y as follows. So yesterday we have seen a definition of marginal distribution. We have one table. So in discussion about table. So as it is, I am writing here that table. Right? So this is marginal distribution nothing but f of x1, f of x2 and so on, f of xm. Similarly, g of y1, g of y2, so on, g of yn. Right? Here we have. So random variable x and y. So this is column is a random variable x. So this row is random variable y. So this I am denoting this is x1 is 1, x2 is 5. Here, give us this. I am writing same. Similarly, random variable y. So this is minus 4 is y1, 2 is y2, 7 is y3. 7 is y3. Then this also given. So 1 by 8. 1 by 8, 1 by 4 as it is. I am shifting table here. So 1 by 8 is j11, 1 by 4 is j12, 1 by 8 is j13. 1 by 4 is j21, 1 by 8 is j22, 1 by 8 is j23. Right? Now, some of these row wise, if we add these all 1 by 2. Right? 1 by 2. How? So 1 by 8 plus 1 by 4 plus 1 by 8. Here I am writing 1 by 8 plus 1 by 4 plus 1 by 8 equal to, here we have LCM is 8. So 1 plus here. So this is here. So we have a 2, then 2 plus 1. So 4 by 8. So 4 by 8 nothing but 1 by 2. Similarly here also 1 by 4, 1 by 8, same value again 1 by 2. So this is I am calling it, this is f of x1, this is f of x2. So these all called as a marginal distribution of f of x1, x2 and so on f of x1. We have only two variables. Similarly, this marginal distribution of g of y1. Now column wise, sum of column wise. So 1 by 8 plus 1 by 4. 1 by 8 plus 1 by 4 is 3 by 8. 1 by 4 plus 1 by 8 is 3 by 8 again. Same value. 1 by 8 plus 1 by 8 is 1 by 4. So this value g of y1, g of y2, g of y. Right? Once you get this marginal distribution, now find these values. Now compute the expectation of x and expectation of y. Now first one, A. Expectation of x equal to, we know the expression, summation I over xi into f of xi equal to, x from this summation, we have I equal to x variable having 2. So x I equal to 1 to 2. 1 to 2. Now x1 f of x1 plus x2 f of x2. Just ಈ summation ಬಿಡಿಸಿದರೆ expand ಮಾಡಿದರೆ x1 ಮಾಡಿದರೆ ಬಂದ x1 into f of x1 plus x2 into f of x2. Then you know the value of x1. x1 is 1. I am writing 1. f of x1 is here right hand side 1 by 2 plus x2 is 5. f of x2 is 1 by 2. 5 into 1 by 2. Now add these. So multiply ಮಾಡಿ add ಮಾಡಿ. 1 into 1 by 2 is 1 by 2. 5 into 1 by 2 is 5 by 2. So 1 by 2 plus 5 by 2 is LCM 2 ಬರ್ತೈತಿ. Then 1 plus 5. So 1 plus 5 6. 6 by 2 is, so 2 1 ja 2 3 ja. Right? So expectation of x is 3. Or we call it as this one is mu of x. Both are same. Expectation of x or mu of x is 3. Similarly, expectation of y. Here running from I and j. Summation j is running from 1 to 3 because you have 3 values. 1, 2, 3. 3 values. Right? Into g of yj equal to, again same, same thing we are following, expanding this summation y1 g of y1 plus y2 g of y2 plus y3 g of y3. Here we have values. y1 is minus 4. Y2 is 2. Y3 is 7. I'm writing minus 4 to 7. Then g of y1 3 by 8. G of y2 3 by 8. G of y3 1 by 4. Then again simplify. This is 4 1 ja 4 2 ja 2 1 ja 2 4 ja. Right? This is minus 3 by 2. Minus 3 by 2 plus again 3 by 4 plus 7 by 4. If we add these 3, so value is 1. Expectation of y equal to 1. So what are we doing? I am writing here minus 3 by 2 plus this is 3 by 4 plus 7 by 4. Now LCM is 4. LCM is 4. Then this is minus 6 plus 3 plus 7 is 4. 4 by 4 is 1. So that value is 1. Right? Then A value we are going to be computing the expectation of x and expectation of y. Then find B1. Compute the B. Expectation of xy. Expectation of xy equal to, you know the expression, summation over ij xi yj jij. This is, you know, the formula, right? Again expand this one. Here we have I equal to 1 and 2 and j is 1 2 3. Why it is I equal to 1 and j equal to 1 2 3? Because this is I, right? This is xi equal to xi. So this is yj. So I equal to 1 here only 2 values. J is 3 values. That's why I am taking I is 1 2 and j is 1 2 3. So that value x1 y1 j11 plus ಏನು ಮಾಡ್ರಿ I fix ಮಾಡ್ರಿ I1 j1 to 3 I2 j1 to 3 like this. x1 y1 j11 plus x1 y2 j1 I1 plus x1 y3 j13. So one row with it plus then I equal to 2 x2 y1 j21 plus x2 y2 j22 plus x2 y3 j23. Right? Now you know the all the values using this table. x1 बताती and y1 बताती. x1 is 1, y1 is minus 4, j11 is 1 by 8. So this is 1 by 8 plus x1 is 1, y2 is 2, j12 is 1 by 4 plus 1, y3 is 7 into j13 is 1 by 8 plus then x2 this value 5 into minus 4 this 5 into 2 this 5 into 7 1 by 8. I am writing here, right? Then now here expectation are similar this one. Now here simplify this, right? Now 4 1 ja 4 2 ja 2 1 ja 2 2 ja. Then we cannot 4 4 then 2 1 ja 2 4 ja 8. So like this. Now here minus 1 by 2 yes plus 1 by 2 plus 7 by 8 minus 5 plus 5 by 4 plus 35 by 8 equal to, after adding these you get a 3 by 2. Expectation of xy is 3 by 2. Right? Then next one is to find standard deviation of random variable x, standard deviation of random variable y. So before that you know that delta x square expression. Delta x square equal to expectation of x square minus mu x square. Now before that find this one, expectation of x square. So expectation of x square is equal to summation over I xi square f of xi. So xi is again the range between I is 1 to have I is 1. x1 what is summation? After expanding this one, x1 square f of x1 plus x2 square f of x2. So x1 is 1, right? 1 square is square root 1 square. So 5 square is 25. 1 square is 1 by 2 into f of x1 is 1 by 2, right? So 5 square is x2 is 5. So 5 square is 25. F of x2 is 1. Now this is, after adding this, 1 by 2 plus 25 by 2. So LCM is 2, then 26 by 2 is, so value is 30. Value is 30. Now expectation of x square is 30. Then you know the mu x. So you have mu x here. Expectation of x. So expectation of x is 3. So here delta x square is 13. This is expectation of x square minus mu x is 3. 3 whole square is this. So 13 minus 3 square is 9. 13 minus 9 is 4. Then take square root of, we have a square because we need only this. Delta x is equal. So if you take square root of both sides, delta x square equal to 4 or delta x equal to 4. Delta x equal to 4. Similarly, delta y square equal to expectation of y square minus mu y square. Then before that, find this value. Expectation of y square equal to summation j yj square f of yj equal to, again same thing, then multiply. Expand this one. So x1 multiply y1 square into f of y1 plus y2 square f of y2 plus y3 square into f of y3. Right? y1 is minus 1 minus 4 square 2 square 7 square. Right? Into this 3 by 8 1 by 4. So delta ಮಾಡಿ you get a 79 by 4. So delta y square is 79 by 4 minus here mu y. So here mu y is 1. Here mu y is 1. So 1 square is 1. So after simplifying here 75 by 4. Right? Similarly, delta y square is 75 by 4 or delta y is x square. So 4.33. Then d1. So d1 is covariance of xy. So covariance of xy. You know the expression equal to expectation of xy minus mu x mu y. So you know the value of expectation of xy is here. This is 3 by 2 minus mu x is 3, mu y is 1. So after simplifying this, minus 3 by, so this is 3 1 is 3, right? LCM 2 over 3, 3 minus 6 by 2, so minus 3 by 2. So covariance of xy is minus 3 by 2. Then finally, correlation. We have an expression for correlation is delta x comma y equal to covariance of x comma y divided by delta x. Sorry, delta x delta. This is rho of x comma y delta x delta. So here we have a covariance of x y is minus 3 by 2. So delta x is 2. Here we have delta x is 2. Delta y is, because we are taking same as this is square root of this 7 by 25 by 4. Because we have 1 by 4 we have a perfect square. That's why as it I am taking. So here, so this is square root of 1 by 4 is, so take outside 1 by 2. So these two, here now these two get cancelled. Now here you have, so minus 3 by 2 into square root of 75. So after simplifying this one, you get correlation of xy is minus 0.173. So this is a required solution of given example.